keynote speaker this morning for the conference, Mrs. Holly Walter Kerby. Holly Walter Kerby is a chemist, a playwright, and educator. She is faculty emeritus in chemistry and creative writing and drama at Madison College, located in Madison, Wisconsin. And she was named the National Community College Faculty Member of the Year in 2012. Her plays have been published, podcast, and produced off-Broadway and across the country. Over the past 2 decades, Holly developed story-based methods to teach science concepts in the classroom and at public outreach events such as the Fusion Science Theater Project funded by the National Science Foundation. Holly teaches science educators how to communicate their work through a highly effective pedagogical approach called Storyform Science. The title of Holly's talk today is Using Secrets of Story to create demonstration shows that teach chemical concepts. Would you please join me in warmly welcoming our keynote speaker, Mrs. Holly Walter Kerby.
That was me, Matt, as I turned on my mic. All right, thank you very much. It's a nice introduction, and thank you for all being here today. So I want to start out by telling you a story. Can you hear me okay? Okay. I want to start out by telling you, well, now I'm in a dead zone. We'll just keep doing this. When I was 8 years old, I got my first chemistry set. Look at it. It's a beauty, right? And look who was on the front of that chemistry set. And I loved my chemistry set. I loved changing one color into the other. Okay? I guess I'm getting a wave. I don't know. Maybe he's just being friendly. And I loved getting things to foam up. That's a big thing. And I like setting fire to things. Now, that wasn't in the chemistry set. I did that by myself. Shh. But what I also like to do afterwards, read books about, why that stuff happened. That was very, very cool. So when I was little, I told adults in my life that I loved chemistry and I wanted to be a chemist. And they had a variety of different responses to me. Like, what? Because I was a girl. But also things like, I'm sorry. They would say things, maybe this is better. Like, what you want to do is to be a researcher. Well, that sounded pretty good to me. And they said, if you want to do that, you have lots of science and math courses. And no messing around with other things. You can't take arts or anything else. Stay focused, which was kind of weird because I really liked arts and other things. But I thought, okay, I'll do that. So in high school, I took a lot of science. Maybe I'll just go right here. It's good. It's good.
Do you want to use this handheld?
Sure. That.
Sorry about that, Holly.
It's just perfect. I feel like I'm on a bad Zoom connection. Can you hear me? You can? Oh, good. Everybody can hear me in the back? Okay, great. So in high school, I took a lot of science courses. And then, in college, I also took a lot of science and math, and I didn't take much else. And then I went to grad school, and I took a bunch of science and math and a whole bunch of research. And although I loved all these things, and actually I was pretty good at them, by the end I thought, I don't really want to be a famous researcher. It doesn't seem to fit me. So I changed my career, and I went into industry, where I made a lot of money. I became a manager in a very short period of time. But I decided I didn't really like that either. So I changed careers again. and I went into teaching, and boy, that was it. That's where I felt like I was home. And I liked it for a lot of reasons. I mean, first of all, I really liked my students. But more than that, I liked to see my students learn. I loved the learning process. I love to watch people like you work hard and put things together, and then it seemed like it transformed people and empowered them, and it also opened lots of doors for them. But it wasn't just my students that learned, it was me too, because in the summer times, I chose not to teach in the summer. I got to read a lot of articles about teaching. I got to go to workshops and things like that, but also I got to write. And I wrote creative stuff and nonfiction stuff, but I also mostly wrote plays. Okay, so what do they say? Flash forward. 20 years, and a student of mine at the community college said, "Would you do a demo show?" I said, "Yeah, I'll do a demo show." Do you know what I'm talking about with a demo show? How many people have been to a demo show? Don't be shy. Okay. So let me tell you about a demo show if you haven't been to one. So a demo show, you go and you get to see a lot of really wonderful chemical education demos. So, things change colors, things foam up, things explode and catch fire. And this was good, I thought, because, I loved the chemistry set. And I actually loved, learning about what happened. Demos are really treasured for being exciting, engaging, inspiring, interesting, and piquing people's curiosity. And that's good for science, right? And I wanted all of that. But I also wanted to help kids learn chemical concepts. Now, by chemical concepts, this is what I mean. It's knowing why something happens, not just what, and knowing it well enough so that you can predict related things. That's my definition, okay? So I went to various articles and websites and stuff, and I tried to look up things that enhance conceptual learning. And here's what I found. I mean, I found a whole bunch of stuff, right? But here's what I found that I thought would be very useful. First of all, participation, right? You learn better when you can participate, correct? Okay, yep. Second of all, inquiry. Science is all about, figuring things out. So if you as a student can do that, that helps your conceptual learning. And last but not least, modeling. In chemistry at least, we have so many models of molecules and all these other kind of things. So that was the third thing. So here was my question. Can I create a chemical demonstration outreach show that includes those best practices? Now, it seemed like a lot to me, right? But I had a secret weapon. There it is. I remember that I had been writing plays for quite a while. And so I knew a whole lot about story. I knew that story was engaging, that it was entertaining, right? But I also knew that under certain circumstances, story could be educational. So I kind of modified my question to be, can a demonstration outreach show that includes best practices using story? Can I do it? So let's start off with what is story? Because for me to launch into this without talking about story seems like, seems like a shame. So what is story? And instead of me just telling you, I'm going to kind of guide us through. And I'm going to guide us through with an example, but not like a particular story because you might not know the story or film. So I'm going to choose a whole genre, and that is the murder mystery. Okay? All right. So murder mysteries, how do they start out? Somebody tell me. Yes. They set up the crime. Now, what do you see almost immediately? Someone's dead, right? Someone's dead. And it was ruled not an accident, right? And so along comes quickly in here some investigator, and it could be a detective, it could be an old lady writer, who knows, right? Anybody can do this sort of thing. And their job is to figure out, like, who committed the murder. Now, a question arises at this time, a question arises in the minds of the audience, the question that now you're watching to see. And what is the main question in a murder mystery? Who did what? In other words, who done it, right? Who did what is much more eloquent than I was going to say, but who done it, which is honestly the oddest contraction I've ever heard, but that's what they're called. And then there's a whole series of things that come about, like, a weapon's recovered, or a witness comes forth, or a motive is revealed. And then there's also, at least in police procedurals, there's that board, right, where they put up pictures, and then they have strings and things, right? And the various clues, I'm going to call them clues and gaps. There's gaps in there because nobody tells you exactly what's going on, right? Sometimes you're like, have they met before? But you have to just keep watching to figure it out. And then that board I'm going to call a representation. It represents how people think. And then there's the outcome where in an exciting scene, the murderer is revealed and then they get their justice. Okay, that's the story structure of almost every story. And that's the story arc, the journey. So let's look for places that the story gives us those best practices. First of all, I just mentioned it was a journey. So who goes on the journey? Yes. The main character, generally. And that, in most murder mysteries, is the detective or the investigator. And they're the ones that, do stuff and do things and have things happen back and people shoot at them and all sorts of stuff. But they're not the only one that goes on the journey. When the audience meets that main character and identifies with them, steps into their shoes, then the audience goes on that journey too. This is called narrative transportation. And it's the reason that when you are watching a really good movie, you feel like you're there. So that's how we're going to get participation in, by doing that. Okay, next thing. Inquiry. Well, we've got that big question up there, who done it, which we want to know the answer. And when does the audience actually get the answer to that question? Tell me. The end, right? Nobody just tells you right away, like you can just go home then, right? It's the end where you get the answer to that question. But you don't just wait, okay, I'm just going to wait and see what the answer is. Instead, with the character, you go ahead and you process all of those clues and gaps and everything. You pay attention, you process information, you understand, and you even predict the ending. Is that right? You predict who did it. And that's higher cognitive functioning. And those things are the hallmarks of inquiry-based learning. And last but not least, modeling. Well, the modeling that I have in mind here is when you see, when the detectives make that, they're taking their thinking and making something physical from it. That's modeling. Okay, so let's do it. Let's use story to design a chemical demonstration outreach show. So, like we said before, there's lots of exciting demos. Here's demo, demo, demo. And then all of those demos in a show get introduced. And then after the demo, generally, if they're done in a traditional way, then those demos get explained after they are done, right? And this could go on and on. I mean, in an hour, you might be able to fit in 10 demos. Now, each one of those demos demonstrates a certain concept. So we can have 10 concepts in 1 hour, which just seemed like a lot for me. I mean, it's hard to learn a concept. So I thought, okay, instead of this, how about if I get some demos that teach the same concept? So I looked and looked and looked to find demos, and finally in the end, I decided that the concept could be conductivity. Now, conductivity is defined as the ability of a substance to conduct electricity. Have you ever seen one of those? Right, we see those little electrodes there. They get dipped into the solution or the liquid substance. A bulb goes in there, gets plugged in, and if you put it in something that conducts electricity, it'll light. And if you put it in something that doesn't, it doesn't light. It's yes or no. So, for conductivity, the demos that are normally used is they test pure water to see if it'll light. They test salt water to see if it'll light, and then sugar water. And then there's always some sort of intro where they talk about this apparatus, so you know what's going on. Now, we don't really need intros for the other thing because they all teach the same concept. So I squished those together. Did you see that? And now I stuck them on the story format, the framework. Well, first of all, we have to have an introduction in story. And what do you know? We have an introduction, right? We're going to talk about that apparatus. I'll stick that there. Next of all, we have to have a character of some sort. And that character will be the demonstrator. But, you know, in a demonstration show, it's not about you. It's about the audience, right? So really, that person is just a stand-in for the audience. And then, let's think about inquiry. In inquiry, you kind of figure things out for yourself, right? It's really maddening. Have you noticed? You want someone just to tell you, but no, you have to figure things out. So let's just get rid of those explanations. Woof, they're gone. Now, another thing with inquiry is we need a question. And with these 3 demonstrations, we could have 3 different questions. We could have, does pure water light the light, does salt water light the light, or will sugar water light the light? And we only need one main one. So let's just pick the pure water. We'll stick that up there. And then, when are we going to show the audience the answer? Where do you see it in the story? Someone tell me. Where are we going to show them the answer? Right away? No, that would make no suspense. Where is it going to be? Yes. At the end, right? Just like in a murder mystery. So we're going to do pure water at the very end. Generate a little interest. Now we have the clues and gaps. So we need something to show the audience to kind of show them what's going on. And let's just use the salt and the sugar. We'll do that in the gap part. And what about now the modeling? Well, that can go up there in that representation part. And the way that they normally talk about conductivity is with a diagram like this. Now you see those 2 poles on either side? Those poles are supposed to represent those electrodes in the conductivity apparatus. And then if you stick it in something that lights, the charged particles in the thing that you stuck it in, these are all very scientific words, that you stuck it in, the positives are going to go to the negatives, and the negatives are going to go to the positive, and that's how it's going to conduct electricity. So we'll just stick that right up there. Okay. Now, one more thing that I didn't talk about with story, but this is about, the whole purpose was to get people to learn this concept, right? So how am I going to know? And this is always a problem. I mean, you're trying to teach something. How do you know? I mean, people could, yeah, I got that. No, not necessarily. So this is the teaching part up there. So let's ask people to predict the answer to the question before the teaching part, and then we'll ask them again before we do it, okay? And if their answers, they get the answer right more afterwards, we'll be happy. And if they get it less, we'll know we have to redo things because it didn't work. Okay, here we go. Here's the show. It's called Will It Light? And it starts with two characters. We have two main characters. We have the scientist, played by yours truly, and also the silent assistant. This guy doesn't talk, he just gestures. And he's hilarious. I mean, everyone loves him. Let's just say that. Okay, so you see down there, he's holding a conductivity apparatus. There we have in the intro. Now we have the question comes next. We're skipping over the problem because the problem really is answering the question. So the question is, will it light? And we're talking about pure water. So I go to test it in front of the kids to answer the question, and the silent assistant comes up with a stop sign and goes, stop, stop. And I'm like, what? What is it? Well, he doesn't say that. He just uses a stop sign. And he says, I want to know what the kids think. And so we have this ballot. And the ballot is, will light bulb light in pure water? I don't know, because it's always okay to say you don't know in science when you're doing an investigation. Yes, it will light. No, it's not going to light. There's the kids filling out those ballots, right? And now we're ready to go ahead and do the clues and the gaps. So we're setting up sugar and salt water, and then we test salt water, so that light goes on, and then we test sugar water, and that light doesn't go on. And now it's time for the modeling. Now, I guess I could just hold up a big sign and go, see, kids, this goes here and this goes over here, you got it? But that's not very participatory, right? So what we did instead is we had volunteers come up and we hung signs around their neck, and we explained about positive and negative charges. They already knew that. And so these kids are modeling a salt crystal. Nice, huh? And then some waters came in, and they're dissolving the salt now. You can see there's a little friction there about the dissolution process between two molecules. But then we turn on those electrodes, and the negatives go to the positive. We have music so they can dance. And then the positives go to the negatives. And then the charged particles sort of pile up at the appropriate electrodes. Now, check out, the water's not doing anything. One of the waters said, how come I am not doing anything? I said, well, are you charged? They looked on their sign, they go, no. I said, then you just dance around. So they did. And then the sugar, we did the same thing for the sugar. Is sugar charged? No, it's not. There's no charge on that sign. So it didn't light. And then the silent assistant says, well, I want to know what the kids think now, because the teaching part is kind of over. So the kids do a second ballot, exactly the same question. And now we're to the climax of the show. All right, so this climax, whenever I do this show with kids, I think, what have I done? This climax is going to be lame. No one's going to like it. I want you to watch the kids. This is being done by some undergrads at an ACS university. Here they go.
Everybody got their answer in? Yeah. Now, Joe, are we sure we're ready to test your what? Are you sure? All right, we're going to try this one more time, okay? Drum roll, please. 3, 2, 1. Okay, so it didn't light. Who can tell me why it didn't light?
And here's the wrap up, a discussion of why. So, did the audience learn the concept?
Well, from that, it kind of looks like they did, and they were pretty happy with themselves too. But let's take a look at the assessment. We had that question, remember? And we asked before and after. So before, we had 31% of the kids got it right, and after, 54%. And given our how many people were involved, 283, that was a significant improvement. And then also we asked the kids if they liked it. So the first one was, did you like the show? I think more than 80% said they either liked it very much or pretty much. And did you understand the science? Same thing, about 80%. Do you want to learn more? I think that only goes up to almost 80%. And then did you have fun? That went over 95%. So using this model with story, see how I just took story and stuck things in? Using this model, we created, this is 6 shows, but I think we created about 10 of them. And we trained undergraduates, and they did the show across the country, and then we made kits, and we distributed them, and people did them all around the country. And we got on the cover of the Journal of Chemical Education, which is pretty impressive because mostly just chemicals are up there, not people. That's good. And I didn't do this myself. Here's my team. Don't worry about their names, but take a look at what they did, their roles. Each one does at least 2 things, and we span the gamut from being a chemical education researcher, to being a playwright, to being an actor, all sorts of things. And I also need to say, of course, that we got a lot of money from the National Science Foundation and other foundations. So, I retired. And then, with my partner, Adam Steinberg, a visual artist, we teach medical professionals and scientists and mathematicians, engineers, anybody with technical content, how to give talks and make visuals that their audience, no matter who their audience is, understand. All right, I'm going to bring it home now, and I'm going to talk about what I know about you. So, I think because you're here, you are interested in science or math or engineering or some STEM field, and that you're probably thinking about possible careers in this, down the line. Wow, that's not supposed to happen. That was one of those aberrant slides that flew in from outer space. I'm going to see if I can get rid of that entirely. Hold on. Here we go. This is the right slide. And I have some advice for you. That was so undramatic that right before my advice, I had this strange slide. I have some advice for you. You're going to have to take a lot of science and math courses. But take things that look interesting. I mean, there's so many possibilities. You should probably do some research if you can, because it's a great experience for you. But, I was told, don't take any science, don't take any math, or don't take any arts or other things. Well, nobody's going to tell you that now, and especially not me. I would suggest that you take arts and music and whatever else. I mean, it shows you what you love, and that shows you who you are. And who knows, you might actually use it in your career going down the line. I ended up doing that, much to my surprise. Now, your career, whatever you're thinking about, sometimes people will talk about it like it's a straight shot. And for some people it is. They know right now, at your age, they know right now what they want to do. But most of us, that's not how it works. Instead, what you need to do is head off in a direction that makes sense, get yourself a job, note what you like, note what you don't like. They're both really useful to know. And then whatever institution you're in, if you tend to not like things as much anymore, well, try to grow that job to fit you. But if at some point you grow so much and your job can't keep up with you or just doesn't fit anymore, then you're going to have to dream about other things you'd like to do. and then find another job. The goal, I had to do this 3 times. The goal is that you find a job that can grow with you and use your whole self. Now, this is when you're changing jobs or dissatisfied or trying to find out the next job, it's uncomfortable. There's that uncertainty, and also there are people who will tell you that you failed at your previous job. Don't believe them. This is how it goes. And it's really worth it, because in the end, you're going to have some sort of a career that's going to allow all the parts of you to fit in there. I didn't say this earlier because I think we all know it. The world has big problems. The world needs scientists. The world needs women scientists. We have a unique perspective. And the world needs you. With all of your unique gifts, you are needed. Thank you.
Holly, thank you. That was brilliant. I love how you integrated the murder mystery genre, which is the best genre in the world, with science. And you know, I'm going to go back to my classroom in computer science and programming and logic and integrate just what Holly introduced. No, but really, thank you so much for sharing your knowledge and your expertise and your strong message of encouragement and inspiration for women in STEM. And at this time, Dr. Harris and I will walk by with a microphone for any questions that you have for our keynote. Thank you again. Yes, I'll take that. Thanks. Yeah.
Hello? Okay. Ask me questions. I feel like I should have a big billboard sign. Ask me questions. Oh, man.
So I know that you said that you did a lot of sort of nonfiction plays and things. Have you ever like written like a fictional thing, or like written like a fictional plot that also incorporated sort of elements of that sort of learning?
I tried. I tried to teach science using a traditional story, and it didn't work. And the reason I think it didn't work is that if you have a traditional story, it's about the main character, right? What you're going to learn in the end is about humanity. And I didn't want people to learn about, who doesn't want to learn about humanity, right? But when I was teaching, I didn't want people to learn about humanity. I wanted them to be the character, and the question to be, can I learn science? Thank you. That's a great question. They do. Thank you for this question. So water is a polar molecule, right? The hydrogens have a partial positive and a partial negative on the oxygen, but they're joined together with covalent bonds. So the hydrogens cannot, okay, so oxygen, hydrogen, right? So hydrogens would want to go towards the negative electrode, right? Can you hear me? And oxygen would want to point itself towards the positive, but we have strong covalent bonds, and we can't separate. So we're stuck. We orient ourselves, but we can't move. Thank you. That was a great question. Again, thanks.
What were some barriers or obstacles that you had to overcome because of your gender in this field?
Well, I'm old, so there were a lot of obstacles. I went to grad school in soil chemistry. There was only one other person in the entire graduate group. I never saw a female professor until I was in grad school. Only men. And when I saw that woman, I was so excited because I was like, I can do that. And she's so good at it. She was dissecting a rat. I was like, I can do that. she's so good at that. And then I watched what she wore. And then, when I went into my job, I only worked with men. And that was hard because they automatically thought I was, going to be hormonal always. So that was hard. And, it's even hard for women playwrights. Every field that I cracked was dominated by men. So it was hard to maintain composure. And you have to work really, this goes for everything, but you have to work really hard at grounding yourself in yourself and having things come out of you and not come out of what other people say about you, which is hard to do, but it's really, you have to do it. It takes a long time. Did I answer that to your satisfaction? Okay. Yep.
I have 2 questions then. I'm over here. For your journey along the way to where you are now, is there anything that you would change or would have done differently?
Yeah, I think I would have tried arts and really worked hard. One of the slides that I got rid of, probably where the weird one came in, was there's never any time, right? When you're studying science, it takes a lot of time. There's never every time. When you go to grad school, there's no time. When you're working, there's no time. But if you look for opportunities, like little spaces in your life to go ahead and take a course or do a YouTube or take a mini course to do arts and other things, you'll find that space. And every little thing you can do will tell you about yourself. So I wish that I had done that way earlier. And I think also I just wish I had been more confident. I was not very confident. But, you look back, right? You look back and you say, why did I do that? How could I have done that? Well, that happens.
And then another question I have is, what would you say to the girl or just people in general that get stuck or discouraged going along trying to find what they want to do?
I would say, yep, that's how it goes. And if you're discouraged because something doesn't fit you, it doesn't mean there's something wrong with you. It means that you've got to, take an inventory. What do I like? What don't I like? And then go from there, trying to find a new space for yourself in the world. And again, that's hard, but you have to do it. It's how it happens. People that just have a clear shot, well, I'm happy for them, but most people are not like that. We all have to keep tacking like a sailboat.
Did you ever, sorry, did I take somebody else's
It's
question?
okay.
Did you ever imagine that you would be, like, this is what you would be doing? What were you originally planning that you would want to do?
No, I had no idea. If you had said, oh, you're going to have your own theater company, and you're going to be teaching kids in outreach, and that gift of yours that you can make up a song out of in 2-3 minutes, which I used a lot doing the theater, I would say, what, you're nuts. That's not true. Or somebody once asked me, they took me out to coffee and they said, so did you always know you were going to have a theater company and be teaching kids in a special sort of innovative way? I said, no, I made it up as I went along. And you don't have to be as weird as me, but we all make it up as we go along.
I guess I just was wondering, so you said you weren't kind of interested in research, like you went that path and then it wasn't really your thing. But then also that this kind of story way of looking at science gave you a new way to kind of introduce it to children especially. But how did it kind of change your perspective as well in research or things that you were looking into, like scientific concepts? How did that help you also understand science better?
I think every time we learn to tell our story and see ourselves in story, we learn something about ourselves. And when I was when I was writing this for you all, I was like, well, shoot, I'm going to tell them that I decided not to be a researcher, although I really think it's very, very valuable, and if you have an opportunity, do it. That I didn't want to do that. And in the end, I'm talking about my research with kids. So there's all kinds of research. I guess, to all your questions, I guess I just had myself in a box. And breaking out of that box was really important. So, yeah, it was amazing that I could do, and I worked with a researcher to do all those things because I knew I didn't have the statistics. Take statistics, too. Did that answer your question?
Yeah,
okay.
thank you.
With the conductivity thing, if it had been water with a different pH level, would it have worked to light up the light bulb, or because with the pH level there would be the ions?
If it had been acidic water, that means that there would have been hydronium ions, like hydrogen ions stuck onto a water, then it would have lit. And that's the one exception, we think of acids as being molecular, but they ionize when they go into water, so then you get your ions.
With going place to place and teaching these kids, how many connections did you get? And would you say that your connections with these people have gotten you to where you are now?
Yeah. I mean, when we started out, we would go around doing these shows. And I made connections within the American Chemical Society, so I went to talk to all their conferences. And then when we trained undergrads, then I got to go and visit all these undergrads, and they came to Madison, Wisconsin to do training with us. And then, people would invite me to speak all over. So in the end, there was a huge, huge network. And I drew people that were really eclectic and did a whole bunch of things. So it was kind of like finding your people, and that happened even before the internet. So it would happen a lot quicker nowadays. But it is, with me teaching scientists, that is something, that is a business, and we do stuff for people all over the world. So yeah, there was a community built. Not only, getting yourself out there, but there was a community that kept expanding, and that was delightful and beautiful.
Have you ever thought about expanding your plays to like the high school level, or even having like high schoolers performing these demonstrations instead of undergraduates?
Absolutely. High school students can definitely perform these plays. Undergraduates were the people I had access to from people I knew at ACS. But there's no reason why high school students couldn't perform these. And I gotta tell you, I think when younger people perform it, it is so much better than when older people perform it. I've got on the stage once, and I had like laryngitis, so I'm up there like croaking. And I see all these kids going, like they're like, Grandma's on the stage and she's gonna die, It's the people that are just a little bit older than the group, and we really shoot from 5 to about 12. 12's getting a little old, not for learning, but just it's not that cool. So I think having high school students do it would be fabulous. So if you're interested, I can get you some kids.
You talked about feeling constrained by your box and being pulled in different directions. So how would you go about not necessarily even just gathering the confidence, but to an extent gathering the confidence and the ability to break out of that box and finding pathways to combine the different aspects of your whole self into one field? Sorry if that was confusing.
Yeah. I think that I did not get validated. And part of that was because it was an earlier time. I don't think that's as hard. But, I think we all wait around to be validated, and when somebody sees us, we're like, whoa, somebody just saw me, even if it was just in passing. But I think for us to wait around to be seen is kind of going at it in a passive way. I think we should look to be validated. And to the other question, look for our community. So, yeah, I mean, you need to be validated. Somebody needs to say, oh, that was good. Even if the pieces don't come together yet for you. So look for people that will validate you and then you can work with.
Of all your accomplishments, which one are you most proud of?
I have 2 kids. I have a grandchild. That's a big deal. As far as all this, I guess just being connected with so many people. And I forgot to tell you, but when I was showing you my team, the beautiful woman up in the left hand, I'm bad with left and right, with the left side, Britland Corver, she's writing a book about how to do these demos, how to pair demos in order to teach a concept. And that's going to get out to, college professors. So I think that's really pretty cool that something came of all this. Thank you for that question.
If you were write an autobiography of your life, what would you name it? What did you give the title?
Oh man, where'd you get that question? It's from a handbook called Stump the Speaker. I don't know. Titles are always the hardest, by the way. That's why they have working title. Maybe that's just what I say, working title. I don't know. Well, I mean, the chemistry sets were really important, so maybe I'd make some homage to chemistry sets, yeah.
Yeah, thank you.
Thank you, and I'll work on that all day, and I'll try to find you later to answer that.
Out of your 2 children, did either of them pursue STEM?
Yes. One is a social worker and, science, One is a social worker. She works with disabled people. And the other one, my youngest daughter, she went to the UW-Madison, and she told people, I am not being a scientist like my parents. Like my husband's a microbiologist, and I was a chemist. She said, I'm not doing that. So, but she was looking around for whatever she could do, and someone goes, have you ever thought of food science? She was like, oh yeah, I like food, that's good. And so she became a food science. Now, funny thing, food science is mostly microbiology and chemistry. But now she's 32, and she has a job at ConAgra, a big food company in Omaha. So she's that career, just with a BS, she's been able to do amazing things and do a lot of research too. So, yeah. Thanks for asking.
How did having kids affect how you pursued your career?
Where are you? Oh, hi.
Hi.
Having kids?
Yeah.
This is all percolating, all your questions. And we were talking about I was talking about getting validation. Well, my kids, they were teenagers when all this was happening. And, when you parent, kids are always pushing on you. That's kind of your job, right? Is to make you grow up. But my kids, in addition to doing that, they were very validating. They would come to all my shows. When we got on the Journal of Chemical Education, there's a high school student in a tutu, and she was my youngest daughter. And so she kept, and honestly, the ringmaster in that would always forget his lines, and she had to feed them to him. So I got to work with her more than my older daughter, but that was huge for me. So they knew how weird I was and how really astonishing it was that all these things could come together. Thank you for that.
I think this is the greatest number of questions we have ever received for a keynote speaker, and they were the best. I mean, they were fantastic. Are there any more before? Oh, one more. And then I think because of the time, I do know that we have to wrap up, but.
Because you got to run and find things, right?
What is the best piece of career advice you've received?
Because I hopped around so much, I don't recall a particular thing that someone said, but here's what I do recall, and that is when high school teachers and then professors in college and then people in grad school, every once in a while someone would see me and they would validate me, and they would give me confidence that I wasn't crazy and that I could do it. And also that I was smart, because I wasn't smart in, there's many ways to be smart, right? And my husband is really he's a scientist. He works with gut microbiome, and he is smart. I'm not smart like that, but I am smart. So for people to say, you are smart, that was important. So again, seek those people out who get you. And don't expect everybody to. I mean, we're all in our own little worlds, right? And as we get older, we expand those worlds and see other people's worlds. But take people for who they are, but seek out the people that you think are going to validate you. I think that was kind of a wimpy answer, but I hope that was okay. All right.
Holly, you are so authentic. You really are all that. I'm so inspired by you, and I can just imagine so are these students, especially with the questions that just were so varied and so inspiring themselves. So
wait, I'm going to be knocking around here for the whole day. So if you see me and you have something want to ask or say to me, then that'd be great. I mean, that's really the best part of the day for me. Thanks.
Thank you. Yes, because you do have your next session to go to, but Holly is going to be around, and we will take up her time and ask her any more questions. Thank you again. See you soon.